So what we have seen in the last session is the first angle projection, the third angle projection. Then how a point in the first quadrant is projected onto the vertical plane and the horizontal plane in order to get the front view as well as the top view, and how we can draw that particular thing in 2 dimensions that we have seen. Now we move on to a point in the second quadrant. So in second quadrant, we know that the point A2, we consider it to be point A2. The point A2 is above the HP and behind the VP. In second quadrant, the second quadrant means it is above the HP and behind the VP. So again, here also we represent it in 2 dimensions as well as 3 dimensions. 3-dimension HP is here, and VP. VP is the vertical plane. I draw it with transparent because it is behind the VP. So now here is the XY line. The XY line is the line or the line of intersection of HP and VP. It is here. Now we draw the XY in 2 dimensions also. In 2-dimensional drawing, in our actual drawing, we represent it in XY line. As a horizontal line. The XY line is drawn as a horizontal line. Now the point, our point is here. This is the point A2. So this is the point A2. Now, as in the previous case, the observer is observing from this direction to get the front view. In order to get the front view, the observer is looking from this direction. Since this object is in this point is in the second quadrant, the vertical plane comes in between the observer and the point. The vertical plane comes in between the observer and the object. So the object is the point. So what we do is we draw a perpendicular ray of light, or perpendicular ray of light, or we assume a perpendicular ray of light which is emanating from A2 and which is traveling towards O. Towards the observer in this case. So it will be like this. And when that particular ray of light intersects with the vertical plane, we get the front view of that particular point, that is A2 dash. So it is like this. So A2, now it is a ray of light traveling towards the observer, and that particular ray of light is perpendicular to VP, so that A2 dash is obtained. A2 dash is the front view. Now the observer moves to the top of the object, the top of the point. And now the ray of light has to travel away from the observer in order to intersect with the HP. So it travels away from the HP, away from the observer in order to intersect with the HP. So when it is intersecting with the HP, it obtains A2 dash, the top view. The top view is the A2 dash. So now what we do is we draw a line from A2 dash and which is perpendicular to the XY line, this blue line. Here comes a blue line. So this blue line is perpendicular to XY and is passing through A2 dash. So we draw that same the line representing this particular line in XY. So in XY we draw it in 2 dimensions. Not in XY, it is in 2 dimensions. In 2 dimensions, this particular blue line is perpendicular to the XY line. This symbol represents 90 degrees. So it is perpendicular to the XY line. And this distance of A2 dash in 2 dimension from XY line should be equal to the length of this particular blue line. The length of this particular blue line should be equal to the distance of A2 from HP. That is how much distance the point A2 is above HP. So that distance is represented by this A2 dash. This particular blue line passing through A2 dash. So that particular distance has to be repeated here. Now, from A2 also we draw a horizontal line, a line which is perpendicular to XY. We draw a line perpendicular to, actually in this case, in the 3 dimension, it is only assumption. We are not drawing it there. It is only assumptions. So in XY line, we assume that a line which is perpendicular to XY is passing through A2. So in these cases, both these lines, both these blue lines should meet the XY line at this point. So in 2 dimensions also it should meet at this point, somewhere here. But in this case, but here this HP is rotated 90-degree clockwise, so that the HP becomes above XY line. The HP again becomes above the XY line. So these 2 lines, this line as well as this line will coincide when we rotate it 90-degree clockwise. So this will be the line. So the line will be coinciding with our previously drawn line, and it will be some more length. It will be having a length which is more than that of A2 dash, because the distance of A2 from the distance of capital A2 from VP is higher than that of the distance from HP. So there is a slight increase in length, and this distance, the distance of XY from A2, or the distance of A2 from XY, is the distance of A2 from VP. The distance of A2 from VP. So that is the distance. So likewise, we can obtain the 2-dimensional drawing. Now, from this one, the conclusion is that if the point is above HP, the front view is above XY. So this A2 dash is the front view, and it is above the XY line. And if the point is behind VP, the top view is also above the XY line. So this A2, that is the top view, that is also above the XY line. This happens because we rotate this horizontal plane 90-degree clockwise, not anti-clockwise. We always rotate it 90-degree clockwise. And by the way, you have to keep in mind that we don't have to draw this particular drawing. This is only for representing it in 3 dimensions. This drawing is to represent it in 3 dimensions. So we don't have to draw this one. What we have to draw in your books is only this one. Whenever you are asked to draw or solve a problem in engineering graphics, you don't have to create a drawing in 3 dimensions. What you have to create is, you have to create the drawing only in 2 dimensions. So if you are asked to draw the projections of a point which is lying in the second quadrant, it will be something like this. Only this much drawing is enough. Whatever is encircled here, only this much drawing is. Only this much drawing is required. Nothing more is required. And now, if we move on to the 3rd quadrant, now I hope all of you understood the concepts, and I won't be elaborating the things. So in 3rd quadrant, the point A3 is below the HP and behind the VP. So in 3D, HP and VP, here is the XY line, and in 2D, this is the XY line, and the point A3 is here. Now the observer is looking from in front of the VP, so that is the VP is in between the observer and the A3 in case of the 3rd angle projection. The VP is, the vertical plane is in between the observer and the point. So the ray of light, the assumed ray of light emanating from or starting from A3 is traveling to O, and this particular ray of light is perpendicular to the VP. So A3 dash is created, or A3 dash is obtained. A3 dash is the front view. Now the observer moves on to the top to observe or to look to A3. And in this case, it is in 3rd quadrant, A3. The point A3 is in 3rd quadrant. So HP comes in between the observer and the point. So here also, the ray of light, the assumed ray of light is traveling from A3 to the observer. So the top view, small letter A3 is obtained here. Now, in order to draw the 2-dimensional representation, we draw or we assume a straight line starting from A3 dash and perpendicular to XY line. And this particular line is drawn here also in the 2-dimension also. The distance doesn't match, will not be matching, because in order to compress all these things in this same slide, I made the distance a slight lesser in 2 dimension, but the concept is the same. So A3 dash is obtained, the distance of A3 dash from XY line will be equal to the distance of capital A3 from the HP. And now we assume a line starting from small a3, the top view of a3, that is small letter a3, and perpendicular to xy line. And we draw the same line in the 2-dimension also. So there the distance of a3 from xy line is equal to the distance of capital A3, the original point, from VP. So that is the condition. Now the conclusions: if the point is below the HP, the front view will be below the XY line. So this is the condition. The front view is below the XY line. And if the point is behind VP, the top view will be above the XY line. So this is the top view. So this is the condition when the point is lying in third quadrant. Now, if the point is lying in fourth quadrant, the point A4 is lying below the HP and in front of the VP, below the HP and in front of the VP. So in 3D, it is like this. This is the XY line. So it is drawn in 2-dimensional drawing, 2-dimensional also. Now here is the point A4. Now the observer, in order to get the front view, the observer is looking away from VP and it is looking to VP. And the object, the point is in between the observer and VP, since it is in the fourth quadrant. And as imagined ray of light is starting from A4 and traveling perpendicular to VP in order to get our A4 dash, the front view. And the observer now moves to the top. Now that in the HP is lying in between A4, the point, and the observer, and an imaginary ray of light starting from A4 is traveling to O. And when that particular imaginary ray of light is intersecting with the HP, we obtain the top view, A4. So now, in order to get or convert this into 2-dimensional drawing, we draw or we assume a straight line starting from A4 and perpendicular to XY. So we draw the same line in 2-dimension also. So in that one, the distance of A4 dash from XY line, A4 dash from XY line will be equal to the distance of A4 from HP, that is marked. So front view is obtained, and then in order to get the top view, we draw we assume a line starting from A4 perpendicular to XY line. A4 means the top view in 3 dimensions. So then perpendicular to the XY line, and the same line is transferred to the 2-dimensional drawing also in order to get A4. So this is the conclusions. Here is, if the point is below HP, the front view will also be below XY. The point is in front of VP, the top view will be below XY. So these are the conclusions. So always keep in mind that always, whatever be the coordinates or whatever be the quadrant in which the point or the line lies, this is always, the horizontal plane is always rotated 90-degree clockwise. So 90-degree clockwise. So in this case, if we rotate this horizontal plane 90-degree clockwise, then A4 as well as A4 dash will come below the XY line. So that is in quadrant 4 condition. Now we move on to the 5th condition, that is the point is in VP and it is above the HP. The point is in VP and above the HP. Sorry. And by the way, I actually forgot one thing to say. When you draw these lines, when you draw the XY line, it should be dark. It should be dark and thick. The XY line should be a dark line as well as a thick line. But this line, this projector line, it should be very thin and very faint line. It should be visible, but it should be very thin line. You use a pencil or in such a way that this line should be very thin and the XY line should be dark or bit thick, not thick enough to measure its distance or its width as 2 millimeter or 3 millimeter. It should be thick enough, but it should not be very thick. So that is, XY line should be dark and thick, and the projector line should be very thin and fade. So now in the fifth condition, the point is the point A5. It is above the HP and is in VP. The point is in VP and above the HP. So in 3D, so this is HP extends to both the sides of the VP, and this is the XY line. So in 2D also the XY line is drawn. So now the point A5 is in VP. It is lying in VP. So when the observer looks from this direction in order to get the front view, since the point is lying in VP itself, there is no need for an imaginary ray of light. Since it is already lying in VP, that particular point will be the front view also. So this is the actual point as well as the front view will be coinciding in this case. So the front view will be here itself. And if the point observer is looking from the top view, from the top in order to get the top view, an imaginary ray of light starting from A5 will be traveling perpendicular to HP. Since the point is lying in VP, this ray of light will be lying, or this they assumed that the imaginary ray of light will be lying in VP itself. It will be lying in VP itself. So when it intersects with the HP, it will be intersecting with the XY also, with the XY line also. So the point A5, that is the top view, will be lying in XY line itself. So the front view will be same as the point that is the which is lying in VP, and the top view will be lying in the XY line. So in order to convert this one into two-dimensional drawing, what you have to draw is, you have to draw a perpendicular line to XY line, and on that line mark the distance of the point A5 from HP. So that is this distance. This distance is to be marked here. This distance is to be marked here also. Here also. This distance. So then A5 dash is marked there. Now A5 will be lying on XY itself, since here the A5 is lying in XY. So it is towards the end of this projector. So this point will be A5. No need to search for another point. So this point is A5 itself. So that is the condition when the point is lying in VP and is above HP. So the conclusions from this condition is that in 3D, if the point is above HP, in 2D, the front view will be above the XY line. But in 3D, if the point is in VP, in 2D, the top view will be on the XY line itself. So that is the condition here. In the fifth condition, where the point is in VP and the point is above the HP. And if the point is below HP and in VP, let's see how is what is the condition. The point A6, which is below the HP and it is in VP. So in 3 dimension, the XY line is here, and in 2 dimension, the XY line is here. The A6, the point A6 is lying in VP but below the HP. So the observer looks, so A6 will be coinciding with A6 dash, or the front view will be coinciding with the original point. And to get the top view, an imaginary ray of light starting from A6 and perpendicular to HP is traveling towards the observer. And since the point is in VP, the imaginary ray of light will also be lying in VP. And when it is, the imaginary ray is intersecting with HP, it will be intersecting with the XY line itself. So this is very simple. XY line, perpendicular, draw a perpendicular to that one, mark the distance of the point from HP and mark the A6 dash there. And the A6 will be lying in XY line itself. So in conclusions, If the point is below HP, the front view will be below XY, and if the point is in VP, the top view will be on XY. Now the seventh condition. Seventh condition, the point is in HP and is in front of VP. The point is in HP and is in front of VP. So let's see how it comes. This is HP, here is VP, here is XY line, then the XY line in 2 dimension. The point is in HP and is in front of VP. So when the observer looks, the ray of light which is starting from A7 and perpendicular to VP is traveling, and this ray of light will be lying in HP itself. So it will be intersecting with the XY line. So it is A7 dash is obtained in XY itself. And in order to get the top view, when the observer looks from the top, there is no need for an imaginary ray of light. Since the point is lying in HP, the top view will also be coinciding with that particular point. So here is A7. So now in the 2 dimension, we can draw a line which is perpendicular to XY line and measure the distance of the point A7 from VP and mark A7. That is the top view. And the front view will be lying in XY line. So conclusions, if the point is in HP, the front view will be on XY. And if the point is in front of VP, the top view will be below the XY line. And the 8th condition, that is the point is in HP and behind the VP. So the shape will be reversed. So HP, XY line, then A8. A8 is behind VP and is in HP. So observer looking for to get the front view. So front view will be obtained in the XY line itself, and the top view will be coinciding with the actual point. So this distance, the distance of the top view A8 from XY line will be equal to the distance of the point A8 from VP, and A8 dash will be lying on XY line. So the conclusions, in 3D, the point is in HP. So in 2D, the front view will be on XY, and in 3D, the point is behind VP, and in 2D, the top view will be above the XY line. So now the last condition. The last condition is the point is both in HP as well as in VP. The point is both in HP as well as in VP. So this is 3D. This is 3D view. That is HP and VP is there. XY line is there. So here is XY in 2 dimension. And the point A9, it is, since it is lying in both HP and VP, it should lie on the XY line itself. So the point A9 is in XY. If the observer is looking from the front in order to get the front view, it will be same as the A9. Since it is lying in VP, the front view should be coinciding with the XY line. So, sorry, since it is lying in HP, since it is lying in HP, the front view should coincide with the XY line. And now the observer looks from the top to get the top view. And here also, since the point is lying in VP, the top view should be lying in the XY line itself. So all the 3 points, that is the actual point, the front view as well as the top view, will be the same point when the point is lying in XY line. So this is A9 dash as well as A9. Both points will be, that is the front view and the top view will be the same as as a single point. It will be the single point on XY line in 2 dimension if the point is lying in XY line. So the conclusions, in 3D, if the point is in HP, in front view, the front view will be on XY, and if the point is in VP, the top view will be on XY. So that is the 9 different conditions. We have discussed the 9 different conditions. That is, the point is in first quadrant, in second quadrant, in third quadrant, in fourth quadrant. And then in VP above HP, in VP below HP, in HP in front of VP, in HP behind VP, and in HP as well as in VP. And we have seen how the drawings will be obtained. Now we move on to the real work, that is the exercises. You write down, note down these questions in your drawing book. Those who doesn't have it along with you, that is it is in your study table and you are sitting somewhere else, please take it and note down these questions. There are 9 questions. All these 9 conditions are given there, and what you have to do is you have to draw all these conditions, all these drawings with the same reference line. On the same reference line you have to draw. You just take your book as well as pencil, scale, protractor, whatever is the all the drawing instruments, the pencil, eraser, etc. will be needed. So take it and write down the questions. I'll give you some 3 minutes. So now I'll explain how to draw it, then you start drawing. So as we said, in the projection of points, first you have to do is you have to draw a horizontal line. In any projection, if you go for a projection, you draw a horizontal straight line. It should be a thick straight line. It should be a thick straight line. And this particular straight line is the XY line. We name it as always XY. So as we said in our first session, what is how to write it, how to write the alphabets that you have to follow. Don't use any artistic works in your X and Y. Now you draw a straight line which is perpendicular to the XY line, very thin line. It should be very thin. I hope it is visible. It may be barely visible, that particular line. So here is that particular vertical line. So draw a vertical line in order to draw the projections. This is the vertical line. It should be very thin line. Now on this one, find the distance of the point from XY line. From the HP, distance of the point from HP. We assume it to be above the HP. When the point is above the HP, we draw the line perpendicular to the XY towards the upper side of XY line. So now measure the distance of that particular point from HP. And then mark this point as A dash. Mark this point as A dash. Now you extend this line, this vertical line, towards the bottom side also. We assume that the point is in the first quadrant, so that is in front of VP. In front of VP. So we extend the line towards the bottom side of the XY line. In order, when you are drawing it, no need to draw it separately, that is the 2 lines separately. You can draw a single vertical line perpendicular to the XY line, and the distance need not end here. It can extend somewhere up or somewhere down, no problem. Even if the projector line, this is the projector line, if that particular line extends away from or extends above the A dash, it doesn't create any problem. It can extend. So no need to look into the dimensions when you started drawing the projector line. You can draw the projector to any length, no problem. Now the only thing is you have to mark the distance A dash properly, that is the distance of the point from HP. Now we move on to finding out the distance of the point from VP, that is in order to get the top view. So the distance of the point from VP is obtained, and that particular distance is marked below the XY line, assuming the point to be in first quadrant. So it is below the XY line. So then that is the point A, that is the top view. So this is the drawing that is required. Now in order to complete this drawing, what we need is the dimensions also. So in order to draw the dimensions, draw a line parallel to the xy line. Here it is parallel to the xy line. Actually, it should be perpendicular to the projector line. Here it is. It should be perpendicular to the projector line. But see the small gap. Small gap should be there between this line as well as this a dash. This point as well as this line, there should be a small gap, a gap of 1 or 2 millimeter, just 1 or 2 millimeter. And this line is also of the thickness of as of this line, this projector line. This line is known as the leader line. So now draw a line which is parallel to our projector line, with the two arrows, with the arrows on both ends. Here is an arrow and here also is an arrow. And this also should be very thin line, It can be darker than this line, but it should not be as dark as this line. It should be very thin line. And now print the distance. In this case, the distance is only representative distance. The distance of the point A from HP. That is the distance of the front view from XY is marked here. And likewise, mark the distance of the top view from XY also. So here it is, like here it is 15 and 10. These distances are only representative. This is not the actual drawing for the exercises that will be coming later. So this is to give you how it is being drawn. So this distance, the distance between these two should be 8 to 10 millimeter. So what you have to do is you have to draw only this, say, only 5 lines are there, only 5 lines to draw the projection of a point. That is, this distance should be 8 to 10 millimeter, and here there should be a distance of 1 millimeter. 1 or 2 millimeter, that you don't have to measure it, but at least 1 or 2, a small gap should be there. It should not be a large gap. And this should also be 8 to 10 millimeter. No need to actually measure it, but at least you must know what is the distance or how much will be there, 8 to 10 millimeter. That you should understand and draw this one. So this is how a projection of a point is being drawn. And this line is projector line, or also known as the projector, that we have already discussed. This particular line is known as the extension line. This horizontal line to mark our dimension, that is the extension line, that we have already discussed. Now this line is the dimension line. So this is how the projection of a point is being done. And now we can move on to our actual drawing. First, I'll just show the animation of how to draw it, and then I go to the OpenBoard software and use the scale and pencil there to draw. And along with that one, you also try to draw. So the projections of points. The first question, since we need to draw 9 different points, projections of points, the better way is to rotate your book in such a way that the horizontal line is the longest line that can be drawn in the book, not the diagonal line. It should be either perpendicular or horizontal. So if you rotate it, it will be the lengthwise you can draw it. So the XY line, it will be a long line. And then for the first question, it was 20 millimeter, if I remember it right, it is 20 millimeter away from HP, that is 20 millimeter above HP and 15 millimeter in front of EP, isn't it?
Yes, sir.
Yeah, the first exercise is 20 millimeter above HP and 15 millimeter in front of EP. So you draw a vertical line or a perpendicular line to XY line and mark a distance of 20 millimeter above the XY line and a distance of 15 millimeter below the XY line. So above 20 millimeter above the XY line, it is the point A dash, and 15 millimeter below the XY line, it is the point A. So this is 20 and here it is 15. So this is the drawing that is required for the first question. For the first question in the exercises, this is the drawing that is required. So now I'll open the open board software and draw how this is being drawn. I am using open board software, but you have to draw it in your notebook. No need to go for the open board software. And the open board software, the drawing in the open board software won't give you any mark also. So I take up the ruler. Since I need a longer line, I am taking it a bit longer, making it a bit longer. And then I draw a straight line. A straight line of sufficient length in order to draw all the 9 drawings. So now this is the line XY. Line XY is drawn. Now I need to draw a line which is perpendicular to this line. So in order to draw that, first I mark a single point here, somewhere on this line towards the left side. So then use the protractor to mark a 90 degree. So the drawing is done. The 90 degree is marked. Now we rotate the scale in such a way that we have to draw the perpendicular line. So we draw the perpendicular line like this. My drawing may not be accurate. There may be some differences in the drawing because some misplacements in the points, because I am not using scale and pencil. I am using the software, so it is a bit difficult to arrange these things. So draw this line and mark a distance of 20 millimeter above this line, above the XY line. So here is the 20 millimeter. And 50 millimeter below the XY line. Since the point is 20 millimeter above HP and 15 millimeter in front of VP, mark these distances. And now name the points. Name these points as this point is A dash. And this point is A. So this is the completion of the projections. But now what we have to do is we need to draw the dimension lines also. So in order to draw the dimension line, we have to draw 2 parallel lines from these points. It should not coincide with our original line. So extend it to some distance. You can extend it towards some distance, no problem. Now here also draw the line. So this is there. Now we need to rotate it so that we can draw the perpendicular line. Here when we are drawing this second line, no need to go for a perfect 90 degree, but as long as possible, make it 90 degree itself. Now draw this line. And now the dimension lines are also there. Now drawing the arrows, my arrows won't be perfect because using mouse drawing the arrows is very difficult, very difficult. So I am just representing the arrows here. You draw it perfectly. This is not a perfect arrow. It looks like an R. So the second arrow should be here, the third one here, and the fourth one here. So 4 arrows. Now print out the dimensions. The dimensions is here it is 20. So it should be as we said, it should be aligned. We use it aligned method. It is always better to go for the aligned procedure. So we go for the aligned value. Now this is 15. So here is it is 50. So this is the first drawing, the first question that we have completed. So if you want to see it zooming, and zoom it, it will be like this. Erase this. So I hope you understood how to draw it. First, to draw the XY line, a horizontal long line, a thick line. Then towards the leftmost point, draw a vertical line, a perpendicular line, which is perpendicular to the XY line. To draw that one, use your protractor. Then on this particular line, mark distance as 20 millimeter above the XY line and 15 millimeter below the XY line. And when you are drawing, it should not be these points. It should not move like this. Only a point will be visible there. Only a point should be visible there, not a line will be visible where you mark A dash as well as A. So this is the first drawing. Now you can draw. You can complete the drawing, and the rest of the drawings, I hope you are able to complete it now, because the concept is clear to you, or the concept is clear to you. You know how to draw it and all these things. When the point is above the XY line, above the HP, the front view is above the XY line. If the front view is, if the point is below the HP, the front view will be below the XY line. If the point is in front of VP, the top view will be below XY line. If the point is behind the VP, the top view will be above the XY line. So that is the way it goes. Now you can draw it. I am moving on to the previous slide itself.